Saturn V Quarterly Film Report Number 4 covers progress during the period September-October-November 1963, highlighting Saturn ground test stage construction. S-1C efforts at Marshall this quarter were primarily in support of the test fuel tank and the static firing test stage. Installation of S-1C test tank upper bulkhead anti-slosh baffles was completed in early October, following receipt of the previously delayed tube supports and splice plates. The lower bulkhead and Y-ring for the test fuel tank were welded together in late September prior to installation of the bulkhead polar cap as originally scheduled to reduce delay to the fuel tank program. The polar cap fit-ups problem for the test fuel tank was resolved by October 1st, and the cap was welded in place. Anti-slosh baffles were later installed, completing assembly of the lower bulkhead. Marshall's recently completed hydrostatic test and vertical assembly building was placed in operation in early November for the first time to accomplish vertical assembly of the S-1C test fuel tank. The fuel tank upper assembly, consisting of bulkhead, Y-ring, and skin section, was first hoisted into the hydrostatic tower, where it remained while the lower assembly was inverted by means of a turning device aboard the C-frame S-1C components transporter. After inversion, the lower assembly was moved inside and lowered into position in the vertical assembly pit. The upper assembly was then lifted by cranes onto the lower assembly for mating. After the proper alignment had been made between the two assemblies, they were joined together by welding. Assembly of the S-1C test fuel tank aft adapter assembly neared completion at Marshall during the report period. Assembly of the fuel tank for the S-1CT, the static firing test stage, got underway this quarter. The lower bulkhead has been completed, and work is in progress on the upper bulkhead. Work on the first LOX bulkhead will begin in December. Welding of cylindrical skin sections began in November. Erection of the main assembly fixture for the S-1CT thrust structure at Marshall has been completed. This, plus installation of the center engine support fixture, essentially completed the Boeing portion of the S-1C tooling erection program. In addition, Boeing also delivered to MSFC all S-1CT fuel tank bulkhead tooling. Assembly of the thrust structure began in November. Construction at Marshall of an S-1C stage simulator by Martin Baltimore was completed in October. The simulator will be used to provide weight and center of gravity data for transportation, handling, and test tower clearances. At Marshall's S-1C static test stand, erection of the steel superstructure was finished this quarter. All deflector support trusses have been emplaced. Installation of the deflector manifolds and piping is underway. Installation of the technical systems for the stand is proceeding on schedule. At Marshall's Michoud operations, Boeing's S-1C activity this quarter consisted largely of installation of tooling and fixtures, such as this upper and lower thrust ring assembly fixture, which was fabricated at Boeing Wichita. In this intertank subassembly fixture, 3 panels will be spliced, forming a 60-degree segment of the intertank. 6 such segments will comprise a full intertank. The first intertank, which was a half of an intertank assembly for the test fuel tank, has been completed and shipped to MSFC. The forward handling ring will be assembled in this fixture at Michoud. The forward handling ring will be used in assembly and transportation of the major components of the S-1C stage and will become part of the transporter for the entire stage. Construction continued on Michoud's vertical assembly building and hydrostatic test stand. By November 1st, Boeing had been granted beneficial occupancy and was installing the bridge crane and other facilities inside the building. At Boeing Wichita, profile milling of the upper cap for the 33-foot-long center engine support has been performed. This is part of the thrust structure assembly. Contouring is necessary to fit the cap to the shear web assemblies. At Boeing Seattle, Saturn V support work continued, including compression testing on a panel simulating the oxidizer tank skin configuration. Test data recorded included applied load versus longitudinal deflection of the panel, ultimate load sustained, strain distribution in the panel versus applied load, and failure mode. At North American Aviation's Space and Information Systems Division, S-2 structural test stage fabrication and assembly continued during the report period at the Seal Beach Final Assembly Facility. By early October, welding was completed on the 12 thick-thin parts required for the aft common static bulkhead. At Seal Beach, the structural steel framing for the vertical assembly building is complete. Functional checkout of the 50-ton capacity gantry crane has been successfully performed. 2 ovens to heat-treat honeycomb cores have been certified. At the Santa Susana Propulsion Field Laboratory facility, the lock storage vessel has been accepted by S&ID, and the liquid hydrogen storage vessel is nearing the testing and cleaning phases. The inner and outer bulkhead domes for the battleship's liquid hydrogen propellant tanks are in the final stage of fabrication. The LOX propellant tank and the inner and outer liquid hydrogen tank walls have been fabricated. The S-2 battleship thrust structure was finished at S&ID's Los Angeles division in November and was delivered to Santa Susana for installation, scheduled to start in December. Deliveries to the COCO-1 battleship test stand this quarter included flame deflector, superstructure, and mechanical and electrical systems. Similar items have been delivered to the COCO-4 all-systems test stand, and the service tower has been erected to over 2/3 of its full elevation. Study of the base area portion of the S-2 electromechanical mock-up has provided S&ID engineers with information pertaining to the installation of the heat shield. 2 J-2 engine simulators were also delivered to S&ID. The simulator is a functional mock-up of the production engine and is used as an advanced vehicle development aid. Valves, electrical, and ignition systems are production hardware and are operational. Components that do not operate during pre-flight checkout are hard mock-ups, but configuration, weight, and installation conform to system design. At Douglas Aircraft's Beta complex in Sacramento, where S-4B stages will be static fired, the superstructure for the battleship test stand Beta 1 was finished in late September. The battleship tank has been assembled, insulation has been installed, and the tank is scheduled for installation in the Beta 1 stand during December. The Beta complex blockhouse was virtually completed during the quarter. At Beta 3, the all-systems test stand, work on the superstructure and propellant storage tanks continued. Activity at the Douglas S-4B mock-up area at Santa Monica included electrical component installation in the aft thrust structure, work on electrical paneling in the aft skirt, installation of the customer connect panels, DAC's mating area to the J-2 engine, work on the instrumentation probe, work on the liquid oxygen probe, and instrumentation wiring of the forward dome. The S-4B auxiliary propulsion subcontractors, Marquardt Company and TAPCO, continued developmental activity during the quarter. Marquardt was engaged in thrust chamber fabrication and testing for its 1,750-pound thrust liquid propellant ullage engine, 2 of which will be used on the S-4B stage. At TAPCO, post-test evaluation and design of a pre-prototype 150 pounds thrust attitude control engine was in progress. Because of development problems encountered, Marshall determined that TAPCO would develop two engines of 150 pounds thrust, one for attitude control requirements for Saturn 1B and 5 vehicles, the other to meet ullage requirements for Saturn V. This decision was made in order that the Saturn 1B schedule might be met. A major milestone in the F1 engine program was achieved on schedule in September with the completion of the first F1 production engine at Rocketdyne's Canoga Park plant. Designated for delivery to the Marshall Space Flight Center, the engine was first shipped for its acceptance testing to the Large Engine Test Area at Edwards Rocket Site. Here, Test Stand 1B2 had been selected for the Static Firing Series, a program in which the engine was subjected to operation under carefully prescribed conditions. In 4 separate firings, the engine successfully met the acceptance testing requirements before being returned to the Rocketdyne plant for final checkout. The longest firing was for 117 seconds. The initial F1 production engine was then transported aboard the Pregnant Guppy aircraft to the Marshall Center. On November 19th, the engine was installed in Marshall's S1 static test stand, one position of which was recently modified to accommodate the F1. Propulsion system testing of the engine was scheduled to begin in early December. At Edwards Rocket Site, construction continued this quarter on a new complex to provide test facilities for production F1 engines and to increase R&D engine test capabilities. Tank installation was accomplished on Stand 1C, and the superstructure was completed on 1E during the report period. To keep pace with the production of both R&D and production engines, new manufacturing facilities have recently been completed at Canoga Park. Over 200,000 square feet of manufacturing space has been added for the use jointly of the F1 and J2 engine programs. Delivery of J2 engines from Rocketdyne's Canoga Park plant to S&ID for the S2 electromechanical mock-up began in late November. A scale model of the altitude facility to be used at the Delta II test stand for the J2 program was tested this quarter at Component Test Lab Number 4 of Rocketdyne's Propulsion Field Laboratory. The Delta II test stand, which affords a 500-second run capability for the J2 engine, was completed in October. The Delta II B position was activated on November 9th with the initial firing of a J2 engine. On November 27th, the first J2 extended duration ground test, a static firing of 510 seconds, was successfully accomplished. The Delta II A position will be activated in early December. At the Marshall Space Flight Center, steel erection for the Saturn V dynamic test stand began in early October. Completion of the 360-foot-tall structure is scheduled in November of 1964. Construction continued this quarter on the Saturn V high-pressure water system at Marshall. The 250 pounds pressure industrial water system, which utilizes huge pipes up to 8 feet in diameter, will have a pumping capacity of 270,000 gallons a minute. Millions of gallons of water will be forced by this system into flame deflectors at the S1C and F1 engine static test stands. At Marshall's Mississippi test operations, Phase 1 dredging of the Pearl River and Little Lake was completed in late October. The MTO construction dock was finished in November. Highway construction is well underway with some access roads also under construction. One of the major buildings under construction is the Warehouse and Emergency Service Building. The Laboratory and Engineering Building, which will serve as MTO headquarters, will be built on this site. Pile driving for the foundations of MTO's S2 static test stand began during the report period, and excavation work for the 350-foot-high S1C static test stand is in progress.